Hello everyone. So welcome to our day three Rotary Camp daily practice. So today our topic is rate, and we also have another important formula that we're gonna do with these questions. Okay, so first, let's read the question. The total output value of a factory from this year to the fifth years. So we want to figure out the total output value of a factory from this year to the fifth year. And what is our requirements? Assuming last year's output value was 1 and the annual growth rate of 10% is 10% compared to the previous years. So depending on these situations, we're gonna figure out what is the total output value of the factory from this year to fifth years. And we know the last year's was 1. Okay, so actually we have this year, second year, third year, fourth year, 5 years. So we have these 5 years over here. So first year, second year, to fifth years. Okay, so if last year's is 1, so if last year's is 1, then what is this year? Annual growth rate is 10%. Yeah, so it's basically 1 plus 10%. So this gave us 1.1. Okay, what about second year? So second year is we growth another 10% based on our previous years. So which means the previous years for the second year is 1.1 already. And we're gonna multiply another 1 plus 10%. So this is 1.1 times 1.1. So we have 1.1 to the power of 2. So third year is really obvious, 1.1 to the power of 3. And until the fifth years, we can get 1.1 to the power of 5. Okay, then we want to figure out the total output of these 5 years. So our problem is basically changes to find the sum of first year plus second year plus third year plus fourth year plus fifth years. Okay. But I'm not sure if everyone familiar with these numbers, but for me, it's really familiar because this one is just what we learned in the previous class. It's called geometric sequence. And we wanna find the sum of the geometric sequence. So what is the geometric sequence? Yeah, geometric sequence is basically we have a series of numbers, we have a sequence of numbers, and they have the common ratio between them. Yeah, so for example, we have 2 times 1.2 and 2.1.2 to the power of 2, and 2 times 1.2 to the power of 3, and so on. So they have the common ratio, which is 1.2. Yeah, so this is what we call the geometric sequence. Okay, and basically we want to find the sum of it. So how many numbers in our geometric sequence? Yes, 1, 2, 3, 4, 5 different numbers. So the formula to find the sum of the geometric sequence, I mean the finite geometric sequence, because we only have limited numbers of sequence. Okay, so we have Sn is equals to A times 1 minus R. R is their common ratios. Basically this one is this, over 1 minus R. And this is only for the absolute value of R is smaller than 1. However, for this sequence, what is their common ratio? The first number is 1.1, second number is 1.1 times 1.1, and third number is 1.1 times 1.1 times 1.1. Yes, so for this problem, the common ratio between each sequence should be 1.1, which is greater than 1. So we're gonna use another formulas, which is A times R to the power of n minus 1 divided by R minus 1. So this one is basically for absolute value of R is greater than 1. Yeah, because it really makes sense because actually all these numbers are positive, right? So if you have some absolute value of R is smaller than 1, you will have some negative numbers. If you use R minus 1, you're gonna divide by negative numbers. Yeah, but if R is greater than 1, then you should get some larger numbers. Okay, so basically we're gonna use these formulas. All right, so how are we gonna use it? So basically here, A means our first term of the sequence. So what is A? Yeah, A is basically 1.1, our first numbers. Okay, and we're gonna figure out R to the power of n. R to the power of n, R is our common ratio. Common ratio is also 1.1. And n is basically how many terms we have. Or you can just figure out its exponents, the last exponents, which is 5. So we have 1.1 to the power of 5 and minus 1. We can copy this one down. And R is their common ratio. Common ratio is 1.1 also, minus 1. So this gave us 1.1 times, oh, this line is not really straight. Yes, we have 1.1 to the power of 5 minus 1 over 0.1. So some number divided by 0.1 means this number times 10. So we have 1.1 times 10 times, this one I'm gonna do a parenthesis, 1.5, no, not 1.5, 1.1 to the power of 5 minus 1. Okay, so this one gave us what? 1.1 times 10 is 11. So 11, 1.1 to the power of 5 minus 1. So the answer is D. So that's our final answers. Did you get it? Okay, see you tomorrow.